So we're going to look through the homework solutions from the other day on graphs of functions and determining whether they are functions and what types of functions they are. So we're shown the graph of a function f such that the real numbers are mapped onto the real numbers on the right. And we're asked, what is the range of the graphed function? So they want to know an inequality for the outputs. What values do the y values range between? So if we look here, the smallest possible output is -1. That will never go below -1, but it will go on forever in the positive direction after that. So the range of this function is -1 to infinity. We do a little round bracket because we can never actually reach infinity. So there's my range. You don't have to write it like that. You could say, for example, that the range is y greater than or equal to -1. Write it like that, or y greater than or equal to -1, or y between -1 and infinity, or in words, anything like that. So any way that you can describe the possible outputs of this function. What is the codomain? Oh, I apologize, guys. Do you know what? I wrote down the wrong thing there. Confusing range and codomain. So codomain, of course, is the outputs that are used. So the possible outputs on my graph, this was the answer here to my codomain. So for part 1, I should have written that the range is the real numbers. Or y an element of the real numbers, or we can even say that y is between infinity and -infinity, or we can actually write it looking like a point like that, from -infinity to infinity. And then my codomain, the actual used outputs, goes from -1 to infinity, or y greater than or equal to -1, or something like that. Okay, so apologies for the confusion then. By comparing the codomain and the range, so this is how they want us to answer it. Explain why f is not surjective. So what we're saying there, if it's not surjective, there are possible values in the range that are not in the codomain. So all we have to do for part 3 is actually give an example. So for part 3, what we would say is, for example, y equal to -2 is in the range, but it's not in the codomain. So I could draw a horizontal line through y equal to -2, and it would never intersect my graph. Suggest a restriction on the codomain to make f a surjective function. Well, again, if we restrict the range to the codomain, it will automatically be surjective. So restrict it to the codomain. To the codomain, and we have y greater than or equal to -1. Y greater than or equal to -1. Use the horizontal line test to show that f is not injective. So we're looking for a horizontal line that will cross my graph more than once. And it doesn't matter where we pick. You could use this one, the y-axis. So the horizontal line y, or the x-axis, y equal to 0. The x-axis crosses the graph twice. It crosses it at x equals 2, and again at x equals 4. So we have 2 values there for the same output. 2 inputs giving me the same output means it's not injective. suggest a restriction on the domain, on my x values, to make f an injective function. So if I cut my quadratic in half and I go between 0 and 3. So for part 6 there, right up here. So for part 6, if I restrict my domain to x values that are less than or equal to 3, it will be injective. Basically halving my quadratic graph so that any horizontal line will never cross it a second time. Okay. Not difficult question, but a little bit tricky, very precise in terms of the terms that we need to use, and you need to have a good understanding of what surjective and injective mean in order to get the restrictions there to answer those last few questions. So do let me know if there's some part of that that you don't understand. Apologies for mixing that up at the beginning. Now, in question 11, explain why this graph is not a function. So you'll remember we've got our horizontal line test for types of functions. But what about if something isn't a function? Well, it's not a function if it fails the vertical line test. If I can draw a vertical line that either doesn't cross my function at all or crosses it multiple times, or doesn't cross my graph, sorry, I shouldn't call it a function, then it can't be a function. So if I draw a vertical line through, for example, x equals 2, it crosses the graph twice. And that would mean that an input of x equals 2 would have 2 possible outputs. And we can't allow that. Okay, so the vertical line test to check if it's a function, and the horizontal line test to check what type of function, injective or surjective. Okay, we're going to move on from the types of functions now.